In this project, you'll combine solid, surface, and form modeling to create a 3D printable Sillcock key. Start by following Fusion's first rule. Create a new component for your Sillcock key. With Activate checked by default, you'll be working inside your new component right away. Keyboard shortcuts appear in the bottom left corner. Open the design shortcuts and search for Create Sketch to begin. Create a new sketch on the horizontal construction plane and draw a center rectangle. I set mine to 10.5 by 10.5 millimeters, reverse engineered from a Sillcock key I measured with a digital caliper. We'll use the Surface Extrude command to turn this sketch into an infinitely thin surface. One advantage of surface modeling is the flexibility it offers later in the design process. By combining solid, surface, and form modeling, you unlock powerful options to shape and refine your designs. Give the surface a thickness of -1 millimeter, or adjust the value to match the requirements of your project. Fillets serve many purposes, adding strength, improving design, enhancing user comfort, and sometimes simply easing corners so the Sillcock key fits. By using the Orbit tool, you can quickly select all edges in one move. This also captures the fillet as a single timeline action, making future edits easier. Offset Plane is a flexible and intuitive Fusion tool that lets you create new sketch planes in relation to your design. I've set this one to 20 millimeters and it will serve as the base for the top of the Sillcock key, where we'll add an eye-catching twist. On the new offset plane, create a center rectangle. Using the origin as the starting point makes future edits easier. I'll set mine to 17.5 by 35 millimeters, an estimated size for the top. With rapid prototyping through 3D printing, it's easy to adjust if the fit or user experience isn't right. A quick way to save time is to jump straight from the sketch environment into your next command without closing the sketch first. For example, by pressing E, we go directly into the Extrude command and, from here, pull the top sketch 3 millimeters down toward the base of the Sillcock key. Before we connect the two 3D models, use the patch command in the surface environment to close the top of the first model. Like all surface modeling tools, this patch has no thickness. By using an extrude join operation, we can give it some thickness for both strength and manufacturing. Fusion often allows multiple workflows to solve the same problem. Share in the comments if you recommend another approach. We're now at the stage of setting up guide rails for the twist that connects the top and bottom. Start from the vertical construction plane and make sure 3D Sketch is active, so you can create the needed sketch lines. We'll use simple straight lines in this example, but I encourage you to get creative and try different tools like arcs or splines. Fusion will automatically help you snap to the center of each filleted corner. Here, we'll connect our line from one of those points down to the bottom edge of a corner on the top model. Repeating this for all 4 corners goes quickly. By orbiting the model and taking a structured approach, we not only connect each part, but also get a chance to quality check the earlier sketch lines from different angles and confirm they connect as intended. If everything looks good, close the sketch. You can always return to this step in the parametric timeline later if you need to make edits. Remember to save your project regularly. Adding a version description before running advanced calculations is a good habit that makes it easier to track your progress. When using Loft to connect parts, you can work with both profiles and rails. By default, you select profiles, which is the most common approach. Adding rails introduces the twist, guiding how the first and second profiles connect. Before closing this step in the timeline, do a quick quality check from different angles to confirm the result. Add a fillet to this part for both usability and appearance. It's a simple final touch that makes a big difference. We'll stick with the basics in this tutorial, but for a more advanced fillet workflow, explore the tangency settings. Form modeling gives us a fast way to add a thumb rest on top of the Sillcock key. Start with a box on top of the design and set the direction and symmetry options so you can adjust it in both directions. Keep it simple for now. You can always return to this step in the timeline later if adjustments are needed. The purpose of this form body is to act as a guide when removing material from the Sillcock key. This is quick and easy to do with a combine cut operation. Well done keeping up with the project. From here, the last step in Fusion is to export your STL file. Use Save as Mesh in the browser to quickly export selected components, then head into your slicer to adjust one key setting before 3D printing. We're now in PrusaSlicer, though the same settings apply in most slicers. Import the STL file and be sure to use the correct units. The Sillcock key will appear centered on the print bed, but since the contact area is small, the print may be unstable. A simple way to fix this is to add a brim around the base. For print settings, I'll use the default quality preset and leave the infill as is. This prototype is printed in PLA, which works fine for testing, but keep in mind that PLA is brittle. Stronger materials are better suited for a functional Sillcock key. The project turned out great, and now I can print unlimited Sillcock keys whenever I need a spare. Check out the 2 recommended Fusion videos for more tutorials to sharpen your maker skills, and see the description for useful links and recommendations. Thanks for watching, and see you in the next project.